What's up? I'm Vin, and today I'm going through the August 2023 Algebra 2 Regents, and I'm going to do parts 2, 3, and 4. I'll leave a link to a copy of these questions in the description below. So now let's get started. Question 25, we're going to factor this expression completely. So when we have four terms like this, we want to factor out the greatest common factor from the first two terms, and we want to factor out the greatest common factor of the last two terms. So for the first two terms, I'm noticing that the greatest common factor is x squared. And now what I'm doing in my head is I'm dividing each term in these first two terms here by the greatest common factor, x squared. So I'm doing 2x to the third divided by x squared, and I'm doing minus 3x squared divided by x squared. And that's what's going to go inside our parentheses here. So when we divide over here, 2x to the third over x squared, just imagine we're doing x to the 3 minus 2 is x to the first. Or we could just see this cancel out completely, and this becomes a 1. So we're going to have 2x, and then we're going to have minus, notice x squared over x squared just cancels, leaving us with 2x minus 3. But now for the next two terms here, we have to be careful. We can't just take out a positive 9, because if we take out a positive 9 here, we're going to have a negative 2x and a positive 3. And notice that this binomial does not match this one. So you want to be strategic here and make sure that when you factor out of the next two terms, that you get a matching binomial for what you have over here. So instead, I'm going to take out a minus 9. And now it's the same thought process. I'm going to divide each of these terms by negative 9. Negative 18x divided by negative 9 is positive 2x. And if I do 27 divided by negative 9, I get negative 3. And now notice what happens at this step here. We have a match. We have 2x minus 3 and 2x minus 3. So now what we could do is we could factor out the 2x minus 3. So we have 2x minus 3, that's coming out. And now we're left with x squared, and we have minus 9 left on this last part here. So if we stop here, this is a very dangerous bear trap, okay? The question is saying to factor completely. And when you hear that phrase, factor completely, just know that you're probably going to have to factor once more. So now the next thing that we need to know is we have a difference of two squares. We have a squared minus b squared, and this factors nicely to a plus b times a minus b. Okay, so this over here, x squared minus 9, we could factor using the difference of two squares, and this is going to factor to, we're going to have x plus 3 times x minus 3. Okay, so this, we're just once again using the difference of two squares factoring. And this is going to be our expression factored completely. Question 26, we want to algebraically determine the values of x that satisfy the system of equations below. Now, I know this question says we have to do the math algebraically, but let's say we don't know how to do the algebra for this question. If we use a method other than algebra, we will get partial credit if we get to the right answers. So in this situation here, for a 2-point question, we would get 1 point. I am going to show the algebra after, but I'm just doing this let's say you know how to do the algebra and you want to check your answer. So we type the two equations into the y1, y2 spot. We press graph, and it may not be obvious as to what's going on here. So what I could do, I know the points of intersection are going to be in this neighborhood here. So maybe I'll switch my window to go from -5 to +5 in the x, and I'll make my y minimum and maximum go from, let's say, -20 to +20. So I'm just adjusting this because it looked like that everything that was happening in this section here. So now I have 2 points of intersection. It may be obvious that it's happening at x equals -1 and +1, but this is another nice trick to know. You press second trace number 5 to trace intersection points, and now you scroll to the neighborhood of the intersection, and you press enter 3 times. And notice we have 1 point of intersection at x equals -1, y equals -12. If I want to find the other one, I press second trace 5, and I scroll to this neighborhood here, and I press enter 3 times. And our second point of intersection occurs at x equals 1, y equals 4. One other thing I could do here is just press second graph and look at the table. And notice at x equals -1 and +1, the y values do match. So now let's go ahead and do this question algebraically. And we know we should get x equals -1 and x equals +1 as the values of x that satisfy the system. So notice they both say y equals. So what we could do here is set these two equations equal to each other. We could say x squared plus 8x minus 5 is equal to, and then we have 8x minus 4. So from here, we have a quadratic equation. We should move everything to one side, so we have 0 on the other side. So I'm going to go minus 8x on this side, and I'm going to go minus 8x on this side. And notice that we have 8x minus 8x canceling on both sides. So we have x squared, and then we're left with minus 5 equals, and we have minus 4 on this side. So we have minus 4, and now to move everything to the left, we're just going to add 4 to both sides. We're going to go plus 4 on both sides. And now on the right side, we have 0, and on the left side, we have x squared minus 1. And notice what we have. We have a difference of two squares again. So this is going to factor nicely to x plus 1 times x minus 1. And we set this equal to 0. But remember, when you have the product of two factors is equal to 0 and the factors have x's in them, what you could do is you could set each factor equal to 0. So we could set x plus 1 equal to 0 to get our first solution, and we set x minus 1 equal to 0 to get our second solution. We'll just make this a little bit neater. So we have x and then minus 1 is equal to 0. So now the first equation we solve by subtracting 1, and we have x equals negative 1 is one answer. And then we have in the second equation, we're going to do plus 1 on both sides. And now minus 1 plus 1 cancels, giving us x equals positive 1. And that's our second solution. Now, one thing I want to point out before we move on, we only have to determine the values of x here. In some situations, when you're solving a system of equations, you have to plug the x back in to get the corresponding y value. But they're only asking specifically for the values of x. And I'm guessing they're doing that because this question is only 2 points. So these are going to be our answers to question 26. Question 27, we're solving this equation and we're going to write our solution in a plus bi form. So what they're saying here is that for this quadratic equation, we're going to get imaginary solutions here. So I'm going to write out the quadratic formula. And if you forget this formula, this is one of the formulas that's actually on the reference page on the back of the test. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So what we're going to do here is just define a, b, and c. So a is our coefficient of x squared is equal to 3. Our b value here is equal to 5. And our value c is equal to 8. So now I just plug into the formula. I'm going to have x equals, and now we have negative 5 plus or minus, and then we have the square root of 5 squared, and then we're writing minus 4 times a times c. Now, one thing I want to point out before we move on here, well, I'll just write out first, divided by 2a, so 2 times 3, is this piece over here is the most common mistake for questions like this. I just want to point out that, let's say this were a situation where b was equal to negative 5. If you were plugging in a negative, just make sure that you put the negative in parentheses, because that's a very common mistake is when students plug negatives in for b, they forget to put it in parentheses before they square it, and the calculator gives them a different answer. Okay, but in this case here, we have b is equal to positive 5. So we don't have to worry about parentheses for this part. But just know that the most common mistake I've seen over the years is when students substitute for the b term, especially when b is negative. So now we'll just type this term in here under the parentheses. We have 5 squared, and we're writing minus 4 times a is equal to 3, and c was equal to 8. So we're just going to do this part here under the radical, and we're going to get negative 71. So now we could write x equals, we have negative 5 plus or minus, and then we have the square root of negative 71 here, all over 6. So for this part, we have to know that the square root of negative 1 is equal to I. Okay, so this is a real big idea for questions like this. The square root of negative 1 is equal to I. So anytime that I have a number under a square root that has a negative attached, I know that I could just bring the negative out of the square root as the term I here. So now I'm just going to simplify this a little bit more. I'm going to write this as we have x equals, and we have negative 5 plus or minus I times the square root of 71 all over 6. But notice for this question here, they told us to write our solution in a plus bi form. So what I'm going to do from here is I'm going to split this up into two fractions. I'm going to write this as x equals negative 5 over 6, and then I'm going to have plus or minus, and notice that we're writing the I term last. So what I'm going to do here is just make sure that I follow their directions 100%. So when I split this second fraction up here, I'm going to group square root of 71 over 6 together. So we're going to have the square root of 71 over 6 and then times I like this. Now, from here, what I personally like to do is I like to write out the answers separately here, because technically we have negative 5 over 6 plus or minus. So that would be two solutions. We have x equals negative 5 over 6 plus the square root of 71 over 6 times I. So this is our first solution. And then our second solution would be x equals, we would have negative 5 over 6 and then minus the square root of 71 over 6 times I. So these are our two solutions to this quadratic equation. If you want to check your answer to a question like this, what you could do is you go over to mode and you switch the mode here from real to a plus bi form. Okay, so we're switching from the real to the complex number system. And now I'm just going to type this in. We have negative 5. So I'm going to press alpha y equals enter to pull up a fraction. We have negative 5 over 6. And then we have for our first solution plus, And then we have another fraction. We have the square root of 71 over 6. So we have second x squared to pull up the square root, 71 over 6. And then to tack on the I at the end, we're going to press second and then over here on the decimal here. Okay, so second decimal brings up the I, and I press enter. And now what I could do is I'm going to press store as alpha math. I'm going to store this as the letter A, so I don't have to keep rewriting this whole mess every single time. And now I go back to the original equation here, and I'm going to type in 3 times our answer was A squared, and then we have plus 5 times A, and then plus 8. And if we did this right, we should get 0. And notice this does work out to 0. So our answer is definitely good. I'm not going to check the second answer, but the second answer will also work out. Question 28, we want to sketch at least one cycle of a cosine function with a midline at y equals -2, an amplitude of 3, and a period of pi over 2. So the fact that they're telling us just to sketch this means we don't have to be the best artist in the world. We just have to get the message across, and we're only sketching at least one cycle of a cosine function. So the first useful piece of information we have is the midline. We have a midline at y equals -2. So that means at this location over here at y equals -2, this represents the midway point between the highest and lowest point of the cosine function. Okay, so I don't think of this as a line of symmetry because it's not going to cut the graph in half, symmetrically. However, it tells us once again the halfway point between the highest and lowest part of the cosine function here. So next we're going to use the amplitude. The amplitude here is 3, and that tells us the distance from the midline to the highest point of the graph. So we're going to go up 3 units from the midline. We're going to go up 1, 2, 3. And if we count up 3 from -2, that's going to bring us to y equals 1. But I also have to go 3 units south of the midline, okay? So I'm going to go 3 units down this way. So I'm going to go 1, 2, 3. And if I do -2 minus 3, that's going to bring me down to a y value of -5. Okay, so that's going to tell us the significant y values here. The next useful piece of information we have is the period, which tells us how far we have to travel in the x direction to complete one full cycle of the graph. And just know that I'm only going to be graphing one cycle here. So I'm going to stop here at pi over 2, and I'm going to start at x equals 0. So any sine or cosine function, you should just know, has 4 sections to it, okay? So keep that number 4 in your mind because we're going to do pi over 2, and we're going to divide pi over 2 by 4. So we're going to have pi over 2 divided by 4. I'm just going to write over 4 over 1 like this. So now I could just do pi over 2 times a fourth, and this is going to work out to pi over 8. Okay, so we have pi over 8. And now what I'm going to do is I'm going to count by pi over 8s. So I'm going to have 1 pi over 8, and then I'm going to have 2 pi over 8. So I have 2 pi over 8, and then next I have 3 pi over 8, and then last I'm going to have 4 pi over 8. And notice that 4 pi over 8 simplifies to pi over 2. So when I cut this into 4 equal sections, this just tells me what my x values are at this or at each of these locations. So this x value here is going to be pi over 8. The next x value I could write pi over 4. I'm just going to reduce this, dividing the top and bottom by 2. So I could write pi over 4. And then my next x value is 3 pi over 8. Okay, so these are the significant x values that we have here. But now since we're dealing with a cosine function, the next thing I'm thinking of is that the cosine function starts up here like this at the maximum, and then it comes down and back up. So it goes maximum here, and then at this x value, we're going to the midline. And then at the next x value, we go to the minimum value here. At the next x value, we go back to the midline, and then at pi over 2, we go back to the maximum, and we complete our full cycle like this. Okay, so now we just connect these points. Okay, and here's one full cycle of the graph. We don't actually have to write a function for this, but if you want to write an actual function for this, this would be the function. If I had to label this would be f of x is equal to, and if we have a period of pi over 2, we just have to think about what's the relationship between the period and the frequency, and there is an inverse relationship between the two. Okay, so this is just a bit extra here, just in case you have to write your own equation at some point. But what I'm thinking about for this part is when I want to write the frequency here, I know that 2 pi divided by the frequency is equal to the period. So if the period is equal to pi over 2, I could just cancel out the pi's like this. And now what I could do is I could just cross multiply. So just imagine I have 1/2 left over here like this. And this tells me that my frequency is equal to 4. So I would just put a 4 next to my coefficient of x in my cosine function. So this would be cosine of 4x, and now the amplitude here is 3. So I'll just put a 3, and then we have cosine of 4x, and we would have to account for the shift here. Our midline is at y equals -2, so I'll just tack on a -2 like this. But once again, they're not asking you to write a function. So this could only get you into trouble, but this is just so that we have a way of checking our answer. If you want to write all of this out formally with an equation, the equation for this particular cosine function, we would have a times cosine of bx and then plus c, where a is the amplitude. So this is our amplitude. This is our frequency. And this is our midline. So now let's just type this in to see that our graph checks out. So we have 3 cosine of 4x, and then we have -2. And for this part, make sure that you are in radian mode. If you're not, go over to mode, and then you scroll down to radians and press enter. So now I press graph, and this gives me an idea of what our function looks like. But let me just go over to what we have here. We have a minimum value at -5 and a maximum value on the y-axis at +1. So I'm going to press window, and I'm going to go over to the y minimum and switch it to -5 and the y maximum to +1. And now notice on the x-axis, we're going from 0 to pi over 2. So I'll go ahead and go over to the x minimum, switch it to 0, and the x maximum, I'll switch to pi over 2. And now if I press graph, notice that I get one full cycle here. So our function is checking out. Question 29, given I is the imaginary unit, we're going to simplify this expression as a polynomial in standard form. So what we're going to do here is we're going to multiply 5x I to the third minus 4i by itself. Okay, since we're squaring this binomial, that just means multiply it by itself. And now from here, we just have to be very careful. Okay, when we multiply these two, please don't do something like this. If you have a plus b times itself, so a plus b times itself, or a plus b squared, please don't say a squared plus b squared. Okay, this is a very dangerous bear trap, and I see this mistake all the time. Please don't do something like this. You have to make sure that you actually use the distributive property. Some people know this as FOIL, but you have to make sure that you send this term here, the 5xi to the third, you multiply it by the first term here and the second term like this, and then you distribute the minus 4i to both the first and last term like this. So we'd have 5 times 5 is 25. So this is equal to 25. We have x times x is x squared. And then we have I to the third times I to the third is I to the 3 plus 3, which is going to give us I to the 6. Okay, so we have this here. And now for the next part here, we're going to have 5xi to the third times negative 4i. So what I'm focusing on, I'm doing 5 times negative 4 is minus 20. And then I have x all on its own here. There's no x term to multiply here. So I'm just going to carry the x forward like this. And we have I to the third times I to the invisible 1 here. So we have I to the third times I to the first is I to the fourth power. And just know that we're doing this once again. We're doing minus 4i times 5xi to the third. So we're having a match here, okay? The terms match. The signs swap here, but we have a negative times a positive is negative. And then we're still doing basically 4i times 5xi to the third to get 20xi to the fourth like this. Okay, so these terms here match. And then last, we have negative 4 times negative 4 is positive 16. And then we have I times I is I squared. So now for this part here, we have to know the powers of I. We have I to the 0 is equal to 1. We have I to the first is just equal to I. And then we have I squared is equal to negative 1. Okay, so this is coming from the idea that when I have the square root of negative 1, this is equal to I. So if I just square both sides, that gives me I squared equals negative 1. And then I have I to the third. Well, that would just be multiplying both sides by I. So I times I squared is I to the third, and I times negative 1 is negative I. But then watch what happens after this. I to the fourth would be the same thing as multiplying negative I times I. So if I did that, if I did negative I times I, I'd have negative I squared, which would be negative 1, which brings me back to positive 1. So notice that this pattern repeats every 4 times, okay? So then I to the fifth would be equal to I. And then if I do I to the 6, I just multiply by I get I squared, and I squared is equal to negative 1. Okay, if I had to find something crazy, like let's say I to the, I don't know, the 107 power like this, the pattern is I just divide by 4, and whatever my remainder is, I just attach my remainder to one of the first 4, and that would tell me what the expression simplifies to. So something like this, I'd have 4 goes into 10 twice, and then I have 4 times 2 is 8, I subtract. So 2 is the remainder, I carry down the 7, and then 4 goes into 27 6 times, and I would have a remainder of 3. Okay, so I write my remainder like this, remainder 3, and that would correspond to I to the third. So this would be equal to I to the third. So this whole thing would be equal to negative I like this. All right, we don't necessarily need to do that in this question because we're only going up to I to the 6. But just know if you had a crazy high power of I, that's what you would do to simplify it. Okay, don't actually sit there and multiply it all the way down the line like this. You will lose your sanity. So now from here, we have 25x squared, and I to the 6 we could replace with negative 1. And then we have minus, we have 20x times I to the 4th is equal to 1. So we have minus 20x times 1. And then minus 20x times 1 again because we have I to the 4th. And then we have plus 16. So we have plus 16 times I squared is negative 1. Okay, so now this will simplify nicely. We have negative 25x squared. And then we have minus 20x is minus 40x. And then we have minus 16. And remember, the question was asking us to write our answer as a polynomial in standard form. So make sure that when you write your final answer that it's starting from the highest power of x and going in descending power order with the constant at the end. So this would be our final answer to 29. Question 30, we have the parabola given by this equation here with this vertex, this focus, and we have to use this information to explain how to determine the equation of the directrix. So for a situation like this, I highly recommend that you get a picture of what's going on. So let's go over to the y equals here, and we're going to type in, we have 1/4, so alpha y equals enter. We have 1/4, and then we have x squared, so we press x, we square it, and then we have plus x plus 8. And now I'm going to press zoom 6 to put the graph back to normal. And notice that we can't really see what's going on here. So if we press second graph, notice that our y values are going up pretty high here to like 19.25-ish. So maybe I'll bump the y max up to 20 and see if this helps. So now we have a much better picture of this parabola. So now that we have a picture from the calculator, honestly, I would probably produce my own sketch of this just so I could zoom in even more. So I'm just going to draw something that looks kind of like this. And they're telling us that the vertex occurs at negative 2, 7 over here like this. And then they tell us the focus is at negative 2, 8. So if this is a height of 7, then the focus is going to be 1 unit up from the vertex. So it's going to be at negative 2, 8. So there's our focus. And this is our vertex. So now the concept of how a parabola is built is that the parabola is the locus or set of all points that are equidistant from the focus, which is a point, and the directrix, which is in this case, a horizontal line. So I know the directrix is going to be somewhere over here because if I take a random point like this, notice that the distance from here to here is the same as the distance from here to here. Okay, so that is once again the concept of what a parabola actually is. So now let's think about this. How does this actually help us determine the equation of the directrix? So once again, I like to draw the picture. The reason being is that when you have a picture, it helps you build your sentence because now you're just describing what you drew. So let's think about how would we come up with an equation for this directrix based on what information they gave us. Well, the vertex is here, and the distance from the vertex to the focus has to be equal to the distance from the vertex to the directrix. So since the focus is 1 unit up this way, see how it's plus 1 unit up on the y direction here, going this way, the directrix would be 1 unit down from the vertex going, once again, going this way. So that would tell us if we're at a vertex here at negative 2, 7, and the focus is at negative 2, 8, the directrix would be 1 unit down from 7. So the directrix would be at the line y equals 6. So the equation would be y equals 6. But now we don't have to actually just write the equation for the directrix. We have to explain how to determine it. Now, one thing I want to point out before we move on, just know that anything from here on is extra because once again, we don't actually have to find the equation of the directrix, but since we spent so much time explaining how to get there, it just felt natural here to just write out what the actual equation is. So the actual equation, once again, is y equals 6. Question 31, we have to write this expression as a single term in simplest form with a rational exponent. So anything here that has a radical involved, we have to know how to convert from radical form to rational exponent form. So when I have something like a to the b over c, just know this is rational exponent form. And this comes from having something like the c root of a to the b power. Okay, so if I have something in this form here, I could go to this form here, rational exponent form. So what I'm seeing right away is we have x times, and then we have the square root of x to the third. Now just note, if there is no number written outside of the radical, the invisible number is a 2. Okay, but square root, we never write the 2 on the outside. So what we have here on bottom, this we could just apply the rule directly. We have x to the power over root. Okay, so the power is this part over here, and the root is the part here in front of the radical. So we go power over root when we are converting from radical to rational exponent form. So let's go ahead and do this. We have x to the power 5 over the root is 3. And now on the top here, we have x times x to the power 3 over the invisible square root. We're going to put a 2 here. And then we have over, once again, x to the 5/3 power. So from this part, now we just have to know law of exponents. When you multiply two exponents that have the same base, so when you have a to the b times a to the c, this is equal to a to the b plus c. And when I have a to the b divided by a to the c, this is a to the b minus c. So first I'm going to multiply these two. So I have to add 1 plus 3 halves. And this I could use a calculator, or just know when I do 1 plus 3 over 2, this is the same thing as doing 2 over 2 plus 3 over 2. I just find common denominators, and that's going to make 5 over 2. So on top, I'll write this over here. We're going to have x to the power 5 over 2. And now we're dividing by x to the 5/3. So now I use this property over here. When I divide exponents with the same base, I subtract their exponents. So now the next thing we're doing is x to the 5 over 2 minus 5/3. And for this part, if I want, I could just use a calculator. So if you don't feel like doing all of this fraction math, you could just do 5 over 2 and then minus 5 over 3. And then once you have your decimal here, just press math, enter, enter. And this is going to be the simplified fraction. So our final answer here, this is going to be equal to x to the power 5 over 6. Now, if you want to see how to do that last bit of math, just know when we have 5 over 2 minus 5 over 3, we could find common denominators. We multiply by 3 over 3 for the first fraction and 2 over 2 for the second fraction. And now we'll have 15 over 6 minus 5 times 2 is 10 over 3 times 2 is 6. And 15 minus 10 is 5. So we get 5 over 6. All right, but on the Algebra 2 regions, you don't have to show all of these gritty steps. You can use the calculator to do this basic subtraction here, and you're going to get x to the 5 over 6. Question 32, we have a fruit fly population can be modeled by the equation P equals, and we have this equation here, where P represents the number of fruit flies after T days. And we want to know what is the average rate of change of the population rounded to the nearest hundredth over the interval from 0 to 10.5. And we have to make sure we include appropriate units of measure in our answer. So for this question here, we have to know the formula for average rate of change. So I automatically think of this formula here. For average rate of change, I'm thinking of f of b minus f of a over b minus a. And this is when you're on the interval ab. So right away for this question, what I want to do is I want to do for the average rate of change, I'm doing the equation here. We're plugging in the endpoints here. So our a value here, just think of our a value here as being equal to 0 and our b value here being equal to 10.5. So I'm plugging in, I'm going to have our average rate of change is 10 times 1.27 to the power 10.5. And then we're subtracting, we have 10 times 1.27 to the 0. Okay, so we're plugging in the endpoints here. So our b value and our a value, we're plugging them into the function, but then we divide by the length of the interval. We're dividing by 10.5 minus 0. Now, one of the things here to be mindful of is the function value is going on top and the independent variable, the difference of those two, is going on bottom. So when I want to write the correct units in the answer, notice that p is representing the dependent variable and t represents the independent variable. So I have my function value on top and my independent variable going on bottom. So when I write out the units here, p represents the number of fruit flies. So on top, I'm going to write fruit flies like this. I'm going to write fruit flies. And then on bottom, so underneath this, the units for the variable t is days. So I have fruit flies per day. So this is just how I stay accurate when I write the units of measurement, is I think of what are the function values units that's going on top. And since p is the function and the units are fruit flies goes up. T is the independent variable and the units are days. Days is going to go in the denominator. So now let's use the calculator to find the average rate of change. And this way that I'm about to show I think is pretty cool. So we have 10 times 1.27 to the power t, but we're going to use x. And now I go back to the main screen by pressing second mode. And what I want to do is I want to use this formula f of b minus f of a over b minus a. So I'm going to press alpha y equals enter. And to write function values on the main screen here, notice we have y equals, we saved the function in the y1 spot. So now what I could do is I could go over to the numerator and I could press alpha trace, and the function was saved in the y1 spot. So I'm going to press 1, and now I'm plugging 10.5 into the function. So I could write y1 parenthesis 10.5 close parenthesis minus, and now I could plug in 0 the same way. I could press alpha trace. If you don't have the newest calculator, you could always press vars. You could go to the right, you go to function, and y1 is at option 1 here. And I'm going to plug in 0 here like this, because notice I'm doing f of b minus f of a. So I'm plugging in 10.5, 0 into the function and subtracting. And now I divide by 10.5 minus 0. We'll pretend we don't know 10.5 minus 0 is 10.5. And here is our average rate of change. So now our answer rounded to the nearest hundredth. We looked at the hundredths place is a 6. To the right is a 2, so we're going to round down to 10.76. And once again, the units here were fruit flies per day. Okay, so we just have to make sure that we write the units to get full credit. So we have fruit flies per day. So here is our solution to question 32. So now we're moving on to the part 3s, and each question here is worth 4 credits. Question 33, first we're going to sketch the function p of x on the axis below, and then we have to describe the end behavior of the function. So let's go over to the y equals, and we're going to type in the function negative log base 2, and to get a custom log, we're going to press math, we're going to hit the up arrow, and we're going to scroll up to log base. We go up 2 more to log base, we hit enter, and notice now we could put a custom base here. We're going to put a base of 2, we hit the right arrow to go inside the parentheses, we're writing x plus 3, and then we get out of the parentheses to write our plus 2. Just know that this log button over here is log base 10. If there's no number written there, the invisible base is 10. And if you were to press this button for natural log, the base of the natural log is e. But we need base 2. That's why we had to hit the math button. So now we could press graph just to get a picture of what's going on. But if we want to be really precise here, what we're going to do is we're going to press second graph to go to the table. And notice that our x values here only give us a y value when we're looking at -2 and then all the other integers greater than -2. If we look at what's happening at x equals -3, we have an error, and for all values less, and that's because logs are only defined when the inside of the log is positive. So we would need x plus 3 to be greater than 0. So this is only going to be defined for x values greater than -3. So something like x equals -2.5 would be okay, but at x equals -3, we're going to have a vertical asymptote. So now let's sketch this out. Remember, we have a vertical asymptote at x equals -3. So we'll just put a -3 here, and we'll sketch our dotted line like this, okay? So we have a vertical line at x equals -3, and this is just going to represent our vertical asymptote. Notice that we have -2, +2 is a point on this curve. So we're going to go over here, up 2 spaces, and we'll say -2, 2 is this point over here, okay? So we have -2 in the x direction, and then y equals 2 is our y coordinate of this point. And then we have -1, 1 is another point on this curve. And then our next point here that we know is the point 1, 0. Okay, so we have a point here at 1, 0 like this. And then we could see that the curve is just going to decrease very, very slowly, but it's going to keep decreasing in this direction. So now when we want to sketch this, we're just going to connect these 3 points, and we're going to make sure that we don't go through the vertical asymptote. So we're going to come down like this. And I'll just label this. This is at the point x equals 1, and the y value here is 0. So we're just going to go down like this. And we connect those points like this. And this doesn't have to be the most amazing drawing in the world. However, it does have to get closer and closer to the vertical asymptote. And we just have these 3 points here. If we want to specify the points that we're using, we could just say that we have a table here, x, p of x. And I'm going to include, we have the point -2, 2 is 1 point on the curve. We have -1, 1, and then we have the point 1, 0. So now we're going to describe the end behavior of p of x as x approaches negative 3. So we'll focus over here at this part of the graph, and let's think about what happens as our x values get closer to negative 3. Notice that the graph here, as we get closer to negative 3, the y values, or the height of the function, is going up to positive infinity. So now we just have to describe this. We're going to say as x approaches negative 3, so as x approaches negative 3, the function values of p of x are approaching positive infinity. And now for the last part of question 33, we're going to describe the end behavior of p of x as x approaches positive infinity. So now we're heading out in this direction here. Let's think about as x goes to infinity, what's happening to the y values of the function. So notice here that the function is just continuing to drop like this. It's dropping very, very, very slowly, but it is continuing to drop. So what we could say is as x approaches, so we'll just make this neater. We're going to say as x approaches positive infinity, the function values here of p of x are approaching minus infinity, okay? And once again, we're saying minus infinity because the graph is dropping, okay? It's decreasing forever and ever, so the y values are going to just keep decreasing towards negative infinity. Question 34, we have to solve for x algebraically. And when you're dealing with a rational equation like this, the concept you want to go with is least common denominators, okay? You want to look at all of those fractions and say, what is the least common denominator of these three fractions? So I'm focusing on this quadratic piece at the end, and my first instinct is to factor this. So I have x squared minus 8x, and then I have plus 12, and this factors nicely to x minus 6 times x minus 2. The giveaway for questions like this is usually the factors involved are going to match the other factors in the question. So that kind of telegraphs it a bit that this is going to factor nicely. But now when I want to identify the least common denominator of these three fractions here is going to be x minus 6 times x minus 2. And this jumps out at me because I could just take this first fraction here and multiply the top and bottom by x minus 2. And it's going to give me a matching denominator, at least with the third fraction, because the third fraction, the denominator is x minus 6 times x minus 2 if we write this in factored form. And now the middle fraction here would be missing the x minus 6. So this one I would just multiply by x minus 6 over x minus 6, and that would get them all to match. So we're going to have 1 over x minus 6, and this fraction, once again, I'm going to multiply by x minus 2 over x minus 2. And then we have x over x minus 2. This second fraction, we're going to multiply by x minus 6 over x minus 6. Okay, so notice that these two fractions now have matching denominators. I know the factors are flipped, but remember, order doesn't matter with multiplication. And now the last fraction after the equal sign is 4 over, and now I could factor it. I factor it as x minus 6 times x minus 2. Now, one thing I want to point out for a question like this, one thing you have to be careful of is you have to make sure that you are not dividing by 0, okay? So look out for division by 0, okay? Because if one of your x solutions makes your denominator of any of your fractions 0, you have to throw that x solution away. So right away, I'm going to say that x cannot be, and I'm going to look at each of these factors involved, and I think, what are the roots of x minus 6 and x minus 2? The roots would be positive 2 and positive 6. And you could think about it. If I plugged in x equals 2 here, I'd have a 2 minus 2 on bottom is 0, and division by 0 is no good. If I plug in 6 over here, 6 minus 6 is 0, and once again, dividing by 0 is no good. So I personally, before I really get moving here, I like to say what x values are not allowed. So now that we've identified the least common denominators of the three fractions, and we've multiplied each fraction in such a way that they all have matching denominators, now we could just cross off all of these denominators like this. Okay, and now we write the leftovers. We have 1 times x minus 2 is x minus 2. And then we have plus, we have x, and we're multiplying that by x minus 6. And we're going to put parentheses here so that we make sure that we distribute. And now the right side here is just equal to 4. So now I could distribute. I'm going to have, after this piece, we have x minus 2 first. And then after we have x times x is x squared. And we have x times negative 6 is negative 6x. And this is equal to 4. So now we could simplify a bit. We're going to have x squared, and now we have x minus 6x. So I'm combining these two to get minus 5x. And then I have a minus 2 on the left side. That's just going to tag along. And this is equal to 4. So now we're getting closer to getting our x solutions. We could subtract 4 on both sides like this. And now the right side is equal to 0. And on the left side, we're going to have x squared minus 5x. And then we have minus 6. So now we think about what two numbers have a sum of -5, and the two numbers also have to have a product of -6. And the two numbers would be -6 and +1. And we could just double check here. If we do -6 plus 1, we get -5. And the product of -6 and 1 is -6. So now we get two roots out of this. Okay, we could write the roots over here. We have x equals 6 and we have x equals -1. If this is not jumping out where those are coming from, I'm setting each factor equal to 0 and I'm solving. Okay, so those two factors over here, we set equal to 0 and we solve. But remember, we said x can't be 2 or 6. So this one here we have to reject. Okay, we're going to reject x equals 6. Our only solution here is x equals -1. Now, one thing I want to point out, they told us to do this question algebraically, but let's say we use a method other than algebra. We would get 2 out of 4 points as long as we're very careful to describe what we did. So if I press alpha y equals enter, and I have 1 over x minus 6, and then after this I have plus, and I'm going to write alpha y equals enter to pull up another fraction, and this time we have x over x minus 2. And then on the right side of the equation, we have 4 over this quadratic. So what I'm going to do is I'm going to subtract this fraction to the left. So I'm going to write after this, I'm going to write minus, and we have alpha y equals enter, and we have 4 over, and we have x squared, and then minus 8x plus 12. So what's happening here is by subtracting this fraction to the left, the right side is equal to 0. So now I could just think about when is this function over here equal to 0. So I press graph, and notice we said x equals -1 was our solution. And notice that the graph crosses the x-axis at x equals -1. If I want to be really precise, I could press second graph, and notice that at x equals -1, we have a root here. So if I want to get 2 out of 4 points, let's say I'm not confident or I don't know how to do this algebra, what I could do is I could just sketch a picture of this function here. I would just, let's say, define a function. I would define the function f of x equals whatever I wrote here and say that this function is equal to 0 at x equals -1, okay? And just like highlight that point on the graph. That would be a method other than doing this algebraically, but it would get you 2 out of 4 points. But once again, if you're not confident in doing the algebra and you think you're going to get a 0 or a 1 out of 4, you're better off just using another method and getting 2 out of 4. Question 35, we want to solve this system of equations algebraically for x, y, and z. Now, I know they told us to do this algebraically, but I recommend that you use the calculator to get the answer up front. That way you know what your work should be heading towards. So we're going to press apps, and we're going to go down here to number 9, to polynomial simultaneous. I'm going to press number 9, and now from here, what we're going to do is we're going to go to the simultaneous equation solver, so number 2. And now we have 3 equations, and we have 3 unknown variables. We have an x, a y, and a z to solve for. So I press all of this, and now I press next by pressing graph. And what I'm going to do is just type everything in. We have 2x, so I press 2x, I press enter, and now I'm going to type in, we have 4, I press enter to go past the plus, and now what we have is, now notice here I could say minus 3z, so I could go back and just make this into a minus like this, and press enter, and then put 3z. Or what I could do, this is just your preference, you could write plus, and then put a -3 like this. Okay, so either one of them is going to get this correct, but I'll just go ahead and make it match exactly. We have minus, enter, and then I'll just write 3z like this. Okay, and this is equal to 12. So now I go to the second row, we have 3x, we have minus, and then we have 2y, and then after 2y, we have plus 2z is equal to -9. And then for the last equation, we have -x. So I'm going to put a minus sign here like this. So, all right, for this, it's an invalid input. And the reason being, we just have to make sure that we put a 1 there after. Okay, so we have -1x like this. And then we press enter, and we're going to write plus 1y. And then we have minus, and then 3z. Okay, so we have -3 times z, and then this is equal to 0. So now to solve, I'm just going to press the graph button over here, and we get our solution to this system. Now, one thing to point out, let's say you don't have confidence in doing this question algebraically. Just like in the previous question, we could say that we used the calculator and describe what we did with the calculator to get to this answer, and we would get 2 out of 4 points for solving this using a method other than algebra. But let's say we want the full credit, we're going to have to solve this system by elimination. So what I'm going to do here is I'm just going to name these equations equation 1, and I'm going to call the second equation, we have equation 2, and then the third equation I'm going to call equation 3. That way, when I just start describing what I'm going to do over here, it's clear which equation I'm grabbing. So what we have is we're looking for variables that will eliminate. And one thing that jumps out at me right away is that we have a negative 2y and a positive y. So I see those are almost matching opposites. So what I want to do is I want to take equation 2 over here. So I'm going to write equation 2, and equation 2 is 3x, and then we have minus 2y, we have plus 2z is equal to, and then we have negative 9. And then I'm going to multiply equation 3 by 2. So I'm going to do 2 times equation 3. And if I multiply everything in this equation by 2, I'm going to have negative 2x. And then I do 2 times y is 2y. And if I do 2 times negative 3z, that's negative 6z like this. And this is equal to, I multiply 0 by 2, and I'm going to get 0. So now when I add these equations together, so I'm going to add these equations together, what we're going to have is 3x plus negative 2x is x. The negative 2y plus 2y is going to cancel. And then we have 2z plus negative 6z is minus 4z. And now this is equal to, we add these two numbers and we're going to get negative 9. Okay, so now we have an equation with two variables. So now what I want to do is I want to eliminate another equation's y term so that I could have two equations involving an x and a z. So notice that we targeted equation 3 and equation 2. So now what I want to do is I want to target equation 1 and equation 2, and between those two equations, I want to eliminate the y variables yet again, okay? So how would I accomplish this? Well, this time around, I would multiply equation 2 by 2, and that would give me a negative 4y, which would eliminate the positive 4y above it, okay? So that's how you use strategy in questions like this. So now I'm just going to record those thoughts. What we're going to do is we're going to multiply equation 2 by 2, and that's going to give us, we're going to have 6x, and then we have minus 4y. So I'm just multiplying everything here by 2, and then we have plus 4z is equal to, and then we have negative 18. And then I'm going to write equation 1 above it. So we have equation 1, and equation 1 is just 2x, and then we have plus 4y, and then we have minus 3z is equal to 12. So now I just add these two equations together. So we're adding this, and what we're going to have is we have 2x plus 6x is 8x. We have 4y plus negative 4y cancels, and then negative 3z plus 4z is 1z. So we have 8x plus 1z equals, and when we add 12 and negative 18, we're going to get negative 6. So now we have these two equations here. Notice that they have an x and a z. So we've turned this crazy system, and we've narrowed it down to just what we have here, and a system of equation with just two variables and two equations. So now we could solve this system here the same way we solve systems in Algebra 1. So we have x minus 4z equals negative 9, and then we have 8x, and we have plus z is equal to, we have negative 6. So now we have to think about which variable we want to eliminate, and I think in this case it's going to be easier to eliminate z. So I'm going to multiply this bottom equation by 4, and that's going to give us, we're going to have x minus 4z is equal to, we have negative 9, and on bottom here, we're going to have 32x. So we're just multiplying everything by 4 plus 4z. And then we do 4 times negative 6 is negative 24. And now from here, we just go ahead and add everything. So we have x plus 32x is 33x. And now negative 4z plus 4z is going to cancel. And this is equal to negative 33. And now we just divide both sides by 33. And this tells us one of the variables here, or the value of one of the variables, x, is equal to, and then we have negative 1. So now we could just plug in x equals negative 1 to any one of these equations here, and let's plug it into the blue one. We would have x equals negative 1. If we plug in, is going to give us, so we'll just show over here, we're going to plug in, we have 8 times negative 1, and then we have plus z is equal to, and we have negative 6. So now we just have to solve this out. So this is going to work out to, we have negative 8 plus z is equal to negative 6, and now we just add 8 to both sides, and this is going to give us, we're going to have z is equal to positive 2. Okay, so now we have our x and we have our z. So to get our y, what we could do is we pick any one of the equations that we started with, and we could plug in the x and the z to solve for y. But let's use the third equation here. That one looks the simplest to use. So what we have is, so using the third equation, we have negative x plus y minus 3z is equal to 0. So now we plug in, we're going to have negative 1 plus y, and then we have minus 3 times z is equal to 2 is equal to 0. And that's going to give us 1 plus y, and we have minus 6 is equal to 0. And now 1 minus 6 is negative 5. So we have y minus 5 is equal to 0, which is going to tell us here that y is equal to 5. So now we have our three variables here solved for. 36 is a simulation question, and we have two classes of students were entered into an experiment to see whether using an interactive whiteboard leads to better grades. It was observed that the mean grade of students in the class with the interactive board was 0.6 points higher than the class without it. To determine if the observed difference is statistically significant, the classes were re-randomized 5,000 times to study these random differences in the mean grades. And then we have the output of the simulation is summarized in the histogram below. And the first thing we want to do here is we have to determine an interval containing the middle 95% of the simulation results, and we're rounding to the nearest hundredth. So when we want to find the middle 95%, the most important thing that you need to know from the histogram here is the mean and the standard deviation. So we have to know that when you're looking for the middle 95%, that you're going to go plus or minus 2 standard deviations from the mean. Okay, so if you just want to have something to follow here, what you're going to do is you're going to take the mean is 0.01 and you're going to subtract 2 standard deviations. So the standard deviation is 0.38. So we're doing minus 2 times 0.38. And now this is going to give us the lower limit of our interval. For the upper limit of our interval, we're going to take the average, 0.01, that's our mean, and we're going to add 2 standard deviations. And this gives us the upper end of our interval. But now, just to get the concept of what's going on, they told us here that the results of the simulation was that we had a mean value here of 0.01. So notice here that the center here is a little bit up here from 0. So that's what we mean when we say 0.01, that's our starting point. But if I go forward 2 standard deviations, and I'm just imagining here 2 standard deviations, if I do 2 times 0.38, so 2 times 0.38, I would get 0.76. And if I look here, if I'm starting at 0.61 and I go forward 0.76, that's going to put me at 0.77, which is almost right between 0.5 and 1.0. So it's somewhere around here. Okay, this is just to give us a visual understanding of what's going on. But notice that if I section off this part of the graph, everything between those 2 points that I just made is going to contain the middle 95%. Okay, so that's what we mean when we say the middle 95% here, that this is going to contain the bulk of all of the results of the simulation. And once again, this comes from going plus or minus 2 standard deviations. But now all we really need is to get the values here. So we have 0.01 and we're subtracting 2 times 0.38. Okay, so we have this, we press enter and we get negative 0.75. And now I could just go up to what I wrote previously and I could scroll up to the minus sign and switch it to a plus. And this is going to tell us the upper limit of our interval here is going to be 0.77. So now we could just record this and notice that our answers are already rounded to the nearest hundredth. So we have negative 0.75 is the lower end of the interval and the upper end of the interval is 0.77. So now for the last part, does the interval indicate that the difference between the class's grades is significant and we have to explain? So for this, we go back to the beginning of the question. And remember, it was observed that the mean grade of the students in the class with the interactive whiteboard was 0.6 points higher than the class without it. And then to determine if the observed difference is statistically significant, this simulation was run. So this is the score or the difference here that we're analyzing, 0.6. We found the middle 95% interval over here. And notice that 0.6 falls on this interval. Okay, so since 0.6 falls in that middle 95%, this 0.6 point difference is not statistically significant. So now for the final question, the part 4 question, this is the final boss and it's worth 6 credits. Question 37, the Manford family started savings accounts for their twins, Abby and Brett, on the day they were born. They invested $8,000 in an account for each child. And then we have Abby's account pays 4.2% annual interest compounded quarterly. So this part here is very important, that Abby's interest is being compounded quarterly. And then next we have Brett's account pays 3.9% annual interest compounded continuously. Okay, so this part here that I'm underlining for both of these kids is very important because it tells us that we're going to need two different formulas. Because first, we have to write a function a of t for Abby's account and a function b of t for Brett's account. And these two functions have to calculate the value of each account after t years. So for this question here, we have to know these two formulas. And just know that for the regions, there's certain formulas that you just have to show up knowing. And the two that I'm about to write are two formulas that you have to know. Unfortunately, these formulas are not written on the reference page on the back of the test. So once again, you just have to know these two. So we have a equals p times 1 plus r over n to the nt power. So this is a formula for compound interest where n represents the number of times per year the interest is being compounded. So the fact that the interest for Abby's account is being compounded quarterly, just think there's 4 quarters in $1. So if the interest is being compounded quarterly, that means the interest is being compounded 4 times per year. Okay, so that would give us n is equal to 4. For Brett's account, his interest is being compounded continuously. So that tells us for Brett, we're going to use the formula a equals pe to the rt. Some people just know this as APERT because it literally spells out APERT. But these are the two formulas that we have to know. And the vocab here, compounded quarterly, compounded continuously, gives it away that we need to know these two formulas. So just know in both formulas, R represents the rate, which is the rate of growth of the account, like the percent here. So what I'm thinking about next for Abby, so we have A of t equals, and for both kids, P represents the principal amount, and they're both starting out with $8,000 in the account. So we have 8,000, and then we have times 1 plus R. And for Abby, just know that R is equal to 4.2%. And 4.2% is the same thing as 4.2 divided by 100. So this you could do in the calculator, or you could just take the decimal and move it 2 spaces to the left. And that's going to give you 0. And we'd have 0.42. Okay, so the R value for Abby is going to be 0.042. And we're dividing this by n, so we're dividing by 4. And now we're raising all of this to the 4t power. Okay, so this is Abby's function here. And now we could just simplify this. We have A of t is equal to, and we have 8,000. And now this we could just type into a calculator. You could just do 1 plus 0.042 divided by 4. And you're going to get 1 point, and you'll have 0.105. And this is being raised up to the 4t power. Okay, so here's Abby's function for her account. For Brett's account, we have B of t is equal to, and we're starting out with 8,000 here. So we have P, and then we have e to the RT. But notice that Brett's interest rate is 3.9%. So we have R equals 3.9%, which is the same thing as 3.9 out of 100, which this would convert to 0.039. Okay, we're just using the same technique as before. So that tells us that Brett's function is 8,000 e to the R, which is 0.039, and then times t like this. Okay, so here are the two functions, and we'll just section these off. These are the two functions for Abby and Brett's account. So now for the next part of this question, we have a few things to do. We have to determine who will have more money in their account when the twins turn 18 years old. And then we have to find the difference in the amounts in the accounts to the nearest cent. So now we could just go to the calculator. We're going to press y equals, and we're going to type in each function. We have 8,000. So 8,000, and then in parentheses, we have 1 point. We have 0.105. We close the parentheses, and we're raising this up to the 4t, but we're going to use 4x. And then for Brett's function, we have 8,000. And now e is second, and then natural log. That pulls up e to the x. And our exponent is 0.039 times t, but once again, we're going to use x. So now we have the two functions. And remember, for the second part of this question, we want to know who has more money at 18 years old. So what we could do is we could press second graph, and we can scroll down to 18, or we could go to the main screen here, and we could press alpha trace y1, and I'm going to put parentheses 18, and then I'm going to close the parentheses here and press enter. And this was Abby's function. So this tells us how much money Abby has after 18 years, okay, when she turns 18 years old. And then if we want to know how much money Brett has, Brett was typed in the Y2 section here. So I go back to the main screen, and I'm going to press alpha trace. If you have an older calculator, you press vars, you go to the right, you go to function, and you go to Y2. And this is just a way of plugging 18 into the function without having to retype everything. Okay, so we have this. And now if we want to find the difference and the amounts in the accounts to the nearest cent, one thing I could do is I could do y1 of 18 minus y2 of 18, or I could just go up to this answer. I could press enter and I hit minus and I go up to the other answer, press enter, and that's just going to type it in faster. So this is the difference of the money in their accounts. So now we could just record these results. We have A of 18. So we plug 18 into Abby's function and we get this value here. We get 16,970. And then after the decimal place, we're rounding to the nearest cent. So we have to go out to the hundredths place. So notice we have a 9 here. We look to the right is another 9. So we're going to round this up to 90. Okay, so that tells us, we'll just make this neater, that Abby, when she turns 18, will have $16,970.90. And now if we look at what Brett has, Brett, when he turns 18, is going to have this value here. Is going to have $16,142 and to the nearest cent, 27 cents. So notice that Abby has more money here. So first we have to determine who will have more money. So we could just make commentary here. We could say that A of 18 is greater than B of 18, and then just write our conclusion. So we'll say that Abby will have more money. So now to find the difference, we're just going to write what we found in the calculator. The difference in their accounts, so now we just do the subtraction here. We could say is A of 18, and then we have minus B of 18. Okay, and these values, once again, we found, subtracted and gave us this value here. We have 828, and then rounding to the nearest cent, this is going to round, so we look at the hundredths place is a 2, to the right is a 5, we're rounding up to 63. So this tells us that the difference, I'll just write with a dollar sign here, is 828.63. Now just know, in terms of the rubric, we do not have to write units of measure throughout the test, okay? Unless they specify to indicate units of measure and to write a sentence with it. In this situation here, we could just write the values like this without the dollar signs. But since they're asking us to write the difference in the amounts in the accounts to the nearest cent, at the end, I'll just put the dollar sign like this. So now for the last part of this question, we have to algebraically determine to the nearest tenth of a year how long it takes for Brett's account to triple in value. So for this, we just have to remember that Brett's account is modeled by this function here. We have B of t is equal to, and then we had 8,000, and then we had e to the power 0.039, and then we have times t in the exponent spot. So just remember, Brett is starting out with $8,000. So a little bit of math we have to be able to do here, and we could use the calculator for this, or we could just think about it. If we want Brett's account to triple, that's 8,000 times 3, because at the beginning, we'll just make this neater, at the beginning, Brett's parents invested $8,000 for him and his sister. Okay, so if we want this amount to triple, just do times 3 and you get 24,000. So we're going to set the value of Brett's account equal to 24,000. All right, so this is how we start the question like this. But now we have to do the algebra to solve for t. Okay, so we have e to the power 0.039 and then times t. So the first thing I would do is just divide both sides by 8,000. Okay, that's just going to make this a lot simpler. It's going to get rid of all these big numbers here. So we get rid of this and this. And now the trailing zeros cross out, and we have 24 divided by 8 is 3. So this represents the account tripling in value. So we have 3 equals, and now we have 0.039 to the t power like this. But now when you want to get rid of e, the opposite of e is natural log. Okay, so this is the algebra that we have to know. So we're going to take the natural log of both sides. So I'm going to have natural log of 3 is equal to, and then we have natural log of e to the 0.039 times t like this. Now, there's a few ways we could go forward from here, but just know that natural log and e basically cancel out. If you want it to be really technical, what you could do is you could use the properties of logs and say natural log of e to this power. We could use the exponent property of logs, and we could bring this exponent inside to the front, and we could write 0.039 times t and then times natural log e. And then just know natural log e, you could use the calculator, is equal to 1. So this just works out to 0.039 times t, because once again, this is just equal to 1. So that is the super technical way to do this, but otherwise just say natural log and e cancel out. And this is going to bring us to the next line. We're going to have natural log of 3. So we have ln 3 is equal to, and we have 0.039 times t. So we're solving for how long this is going to take. So we're solving for t. So now we just divide both sides by 0.039. And this is going to tell us how long it takes Brett's account to triple. So we just cancel this out, And now to get the value of t, we're just going to plug into the calculator. So let's just make a fraction. We have alpha y equals enter, and we want to know what is natural log 3. So we have natural log 3 on top, and we're dividing by 0.039. Okay, and we're rounding this. In the beginning of the question, they told us to round to the nearest tenth, okay, to the nearest tenth of a year. So we're going to round this to 28.2. So our solution, we're going to say t equals 28.2 years. And once again, this is how long it's going to take Brett's account to triple in value.